Thank you, and I'm very happy to be here, and I'm really happy to be talking about SASE. And the primary mission of SASE is what's said here, the convergence of networking and security. That's really key. And when we talk about the convergence, we're talking about a single type of integration of the management plane, of the management console, policy management, data lake, just an overall unified experience between networking and security. So what is SASE? Well, SASE covers a lot of different things. We have a list of features here: SD-WAN, firewall, secure web gateway, zero trust network access, CASB, and then some other functions at the bottom: digital experience monitoring, remote browser isolation, and a bunch of other features. But when we look at the components, SASE includes SSE, or Security Service Edge, and SD-WAN. The core components of SSE are SWG, or Secure Web Gateway, ZTNA, Zero Trust Network Access, and CASB, Cloud Access Security Broker. Those are the core components. And when you look at all this, they're cloud delivered, primarily cloud delivered. So that's the main point here. Now we add the broader kind of capabilities, SD-WAN and firewall. That is what brings you to SASE. Now, mind you, firewall can be delivered as firewall as a service. It could be a little bit more on the SSE side, or it can be integrated with SD-WAN, be a little bit more on the SD-WAN side. But the bottom line is here is SSE and SD-WAN together make up SASE. So what are the drivers? And there are two main drivers for SASE. One is the hybrid work. The workers are increasingly everywhere, and they've been this way, accelerated by the pandemic. Users and employees, workers who are not only in the office, but working from everywhere and working at remote location, working at a coffee shop, airport, hotel, you name it. We also have the impact from the cloud adoption. Applications are not only in the data center anymore, and that's been going on for years. So let me kind of give you the example. It used to be that in some cases, some organizations are still like this. Users are in campus branch environments. They're connecting in a private network to a data center with their apps are there. That's primarily how things used to be. And that was very well defined. The apps in the data center, the users in on-prem, and that's well defined. But as you had more and more apps moving to the cloud, the security team liked traffic to go through the data center. So the security team likes when traffic is centralized and security centralized and reducing the security perimeter. Networking teams don't like centralization as much because it increases latency. I don't want to backhaul traffic to add latency. I want to go directly to where the traffic is or where the resource is, the application is, so I can reduce the latency. So that when you had enough cloud traffic that was driving this remote users or users in general connecting to cloud, there was a drive to bypass the data center and go directly to the cloud. So that changed the security architecture. Security architecture moving more to the cloud because of these cloud resources. And the users, highly distributed, can access that security regardless of the art because it is delivered in the cloud. The cloud is more centralized, so that's the benefit for the security teams, and the networking teams get the benefit because the users are connecting directly to the cloud resources and lowering latency. So again, the bottom line is hybrid work, workers not only in the campus or branch, but everywhere now to access workloads that are primarily in the cloud and in the data center, but not only in the data center. And the cloud adoption, acceleration of that has really driven it. The breadth of cloud, where the apps are, and the breadth of where users are driving this. So why SASE? Well, it comes down to several things and more, frankly, that users care about. But the primary ones are administrative efficiency. How do I simplify this? Organizations in general are looking for simplicity. They want to consolidate vendors, consolidate management consoles, and they just want less steps, less configurations, just overall, how do I make things easier to manage in my environment? And then you have also the aligned with modern traffic patterns. We just talked about this. The users who can be anywhere accessing resources in the cloud, and how do I minimize latency while still providing the necessary security? Improving performance, same lines. How do I minimize my latency and having a single pass architecture also? I don't want to send my traffic to different types of security functions and impacting performance. I want to have a single pass. So every time the traffic goes by, I want to apply all the security and networking functions at the same time and leverage that. And applying zero trust principles, by default, no one is granted access to a network. By identity, you have to prove your access to the network. And is SASE the only way to deliver zero trust? No, but it is increasingly becoming a main way to deliver zero trust. So what do clients prioritize in a SASE product? And we asked this question recently in a survey. And among other things, the simple unified type of management consolidation of vendors and want a single security policy, unified policy across all aspects of networking security. All that is really important. Cost is important. But what sticks out is that security features are prioritized over networking features. And in this case, 3.5 to 1, that security features are a higher priority than networking features. And I'll give an example of discussions I have with clients. And I'm a networking analyst. And when I have SASE conversations, more often than not, probably even higher than the 70% I'd estimate, when someone says SASE, they're really having a security discussion. So whether it's on our inquiry discussion or on these surveys here, it's definitely true that security features are prioritized over networking features. What are the different SASE models? Well, you may have heard these terms before, but they're all SASE. One here is dual vendor SASE. So what does that mean? It means one vendor that has the SD-WAN functions and one vendor that's delivering the SSE functions. Vendors. Now, SSE is having that consolidation as well. We spoke before about the CASB, the ZTNA, the secure web gateway. All those are consolidating on the SSE side, and then you bring in the SD-WAN side, further integration, but two different vendors. Again, SD-WAN, one vendor, SSE from a different vendor. Now we also have SASE platforms, and that's also been known as single vendor SASE, but SASE platforms implies a tighter integration between the SSE and the SD-WAN component. And then finally, we have managed SASE, a third-party managed service provider that's managing this infrastructure on behalf of the end user. So you look at specifically on dual vendor SASE, you notice we say two vendors, dual meaning two, SASE platform meaning one, and then these all focus into SASE. But the point is this: there's a lot of SASE that's called SASE that really isn't SASE out there. And it's when you have 3 or more vendors. And we call that loosely FrankenSASE. It's more of a slang term. But nonetheless, what it implies is that I am getting all these functions, but I'm not giving the integration. I am not getting a single pass architecture. I am not providing a unification. While I'm getting all these kind of functions, I'm not delivering in a way that would be elegant for SASE. So that's why there's a lot of that functions out there. I can have more than, let's say, or more SSE vendors than an SD-WAN vendor. Is not the spirit of SASE, although the functions are being delivered. Need to be clear, no more than 2 vendors. So let's talk about the SASE platforms angle. And all these functions need to be considered and delivered from the same vendor in an integrated control and management plane. That's what this is saying. Now, you could lump the SD-WAN functions and the firewall functions together in the ZTNA, SWIG, and CASB together. And again, firewall can be firewall as a service, or it can be integrated with SD-WAN. But the point is that all these are delivered from a single vendor. If you had a dual vendor, you would have the SD-WAN and maybe firewall together, and ZTNA, SWIG, CASB delivered. And again, the firewall can kind of go either way. But the bottom line is that's how these boxes would play out. But from this perspective, one vendor is delivering all this. So in support of this SASE platform move and what we at Gartner predict will happen over time, these are specific strategic planning assumptions, SPAs for short, that we've written in our research. And I'll go through all of them pretty quickly here. First one is saying by 2028, 70% of SD-WAN purchases will be part of a single vendor SASE platform offering, which is an increase of 25% today. It's not saying the overall market will be that 28. What it's saying is purchases that are made that year, SD-WAN is becoming more and more of a feature of SASE and SASE platforms, to be more specific. By 2026, the next one here is the majority of SASE vendors will offer a completely converged single vendor SASE offering. One kind of management console, single policy management, single data lake, these kinds of things. We're on our way to that. We're not quite there, but we're on our way. for that, and that's kind of the real spirit of SASE. By 2028, the next one, 50% of new SASE deployments will be based on a single vendor SASE offering, up from 25% just last year. Now, what that is saying, we've written some research where I think last year we said 1 out of every 4, and this is what this is saying here, 1 out of every 4 inquiries that we get would be for single vendor, and the other 3 would be for dual vendor SASE. And this year we're seeing that 1 out of every 3, so I'll call it 33% in 2025. You may say, okay, that's moving, but historically, call it 3 or 4 years ago, it was maybe 1 in 5 or 1 in 10 that was single vendor because it's a newer market. The point is the conversations and what we're saying is by 2028, the break even between the purchases between single vendor SASE or SASE platforms and dual vendor will happen by 2028. And the last one is saying by 2028, 30% of large organizations with expiring dual vendor SASE contracts, so a contract with SD-WAN, a contract with SSE, will not renew those. In fact, converge on a single vendor to do everything. So these are different type of predictions, all converging on the direction of SASE platforms. So let's shift here to zero trust. We talked about the zero trust earlier, that SASE is a way to deliver zero trust. And we have 2 components to this. One is the default deny, right? So essentially, I don't have trust. I'm not trusting anyone. I don't have implicit trust be able to say that this organization or this user is able to join this network. I'm assuming that this person does not have access, and you have to prove to have access. So there's, based on identity and some other metrics that we'll get into, you're granted access based on passing these tests. And then there has to be risk appropriated access to certain resources, meaning I'm not getting access to everything. I'm given least privilege access. What's the minimum I need to do my job or I have access to in the applications? And then ultimately, there's a process that continually updates this. Now, more specifically, we defined zero trust networking as the following. And as we were just saying, is that a user or device has access to a network based on who they are and their identity. But then there's context, right? There's context of that user that's granted on their identity to which resource they're granted, which resource they have access to. Again, they're not granted access to everything. It's only to what they're required to have access to. And then what's also unique is this is the risk assessment, the posture of that remote user or device is constantly updated. What software do I have on my machine? Are the most recent updates and software, is that all updated? Do I have the most recent versions on it? Security patches? Which websites have I gone to? Where have I been? That's tracked. And does that pose a threat to the rest of the network? And if it does, it can restrict access based on that to not infect or impact the rest of the network. So it's not only granting access, but it's also identity of the user or device to make sure it is safe to access the network. And that's continuously done. So let's look more on ZTNA and how that is playing out to the broader future. Now, tell a quick story with Zero Trust Network Access. It's primarily for remote users, remote workers. And it really accelerated during the pandemic. And early on in the pandemic, we had more of this, or VPNs. And overnight, we had people went from working, almost no one working remote to almost everyone working remote. And VPN concentrators and routers had to be updated. Firewalls had to be updated because it wasn't meant to handle that traffic. Whereas ZTNA is more of a cloud service, or the VPN termination is primarily on-prem. So ZTNA more cloud, but as a result of this, being cloud is one aspect of it. But the reality is that this had a different way to access the network, as we were talking before, is that it was granted least privilege access, so the minimum access to resources as needed. And then it was updated based on the risk posture of the individual, the user or device, and continuously updated. IT departments really like that. So saying, look, I want to, from that model on that remote user accessing that way to my overall campus, I want to have a consistent platform across everything. And I like the way it's more by default not accepting the access to the network and getting access only based on identity and the resource access based on what are allowed to reach. So that concept is really interesting to be deployed everywhere. So how do we compare this? We look at UZTNA or Universal ZTNA, and we look at traditional NAC, that is network access control plus a remote access solution of some kind. And when you look at that, different user experience. So it's a little more complicated. UZTNA, same user experience. You can have it at your remote office. You can have it in your coffee shop, your hotel, airport, wherever it happens to be. From a management standpoint, it's one management console for UZTNA and multiple for NAC plus the remote access. Same thing with policy engine. You're going to have different types of policies based on the solution on the left with NAC plus remote access versus UZTNA. Regardless of where you are, it's the same policy. And then on the left-hand side, it's pretty much a little more static. No near real-time access judgments after connecting to calculate the risk score. Or on the UZTNA, that is constantly done. If the risk score changes, that user and remote or device will not be granted access to the network. On the left-hand side, more coarse-grained VLAN level kind of access, more networking level access, versus on the right-hand side with UZTNA, it's more application level access, restricting access to application. So consequently, we view the next few years that the NAC business, the network access control business, will diminish by up to half because of these reasons and simplifying the end user, remote user, and on campus to kind of integrate that together. So let's shift now to the future of SASE. What are we looking for in the next 3 years? Now, this is just an example set of thoughts. It's certainly going to be broader than this. We have vendor consolidation that's always happening. We have SD branch and SASE kind of converging. AI can't have a conversation these days without AI, post-quantum cryptography, sovereign SASE, and support for managed devices. So let's get a little more detail. I know there's a lot here on this slide, and there is. But the point here is in the left-hand side, we have secure access service edge. That's not changing. The boundaries of secure access service edge are pretty well defined. SSE and SD-WAN and the SSE functions are pretty well defined. SWIG, CASB, ZTNA, and the other functions as well. Now, you have these ancillary functions that are represented by the right part of the graphic here, but a lot of these are more SecOps, security operations functions. At its core, SASE is more of an infrastructure and security, certainly, but not necessarily as much a SecOps buyer. But you're seeing there's convergence here. There is convergence, but it's not like SASE is going to absorb these functions. It's more that, yes, vendors will bring them together, but SASE is still going to say what SASE is and sell to its constituents. Next, we have SD branch meets SASE. SD branch fundamentally means I'm taking my campus environment, access point switches, SD-WAN, and firewall as a common orchestrated solution. I can package that together like that. But then SASE, on the other hand, is very similar. The SD-WAN is kind of in both these areas. SD-WAN is in the SD branch part, but it's also in SASE. So you have SASE being SD-WAN plus the cloud security, but SD-WAN plus SD branch as well. So we are seeing this convergence of more and more convergence. So it's kind of similar even to the previous topic, another example of vendor consolidation. So we expect to see this. I will also say that we see more and more examples of things like coffee shop networking, where this is kind of similar, where the applications are primarily in the cloud. You don't have as much on-prem workloads at all. Everything's in the cloud. I don't have as much need for east-west security locally. I want to connect via Wi-Fi in a similar way that I would connect at a coffee shop or wherever it happens to be. I want to be able to connect in the same way everywhere and make my campus like that. The coffee shop networking example is making your campus, your branch, looking like that, so it's easy for a user, bringing that. So that goes back to that hybrid work example as well. Now let's talk about AI. Again, I said you can't have a presentation without AI. Here's that. So there's a few things going on here. One is securing access to Gen AI apps. Do I, as a user, have access and rights to use Gen AI? Maybe, maybe not. There are tools that will allow that or prevent that based on what the company wants. But also when I am granted access, how am I controlling and managing the prompts? Can I control the prompts and make sure there's no data leakage? Nothing proprietary is being sent in those prompts. So that's what's happened. It's restricting access or controlling access, but it's also monitoring the prompts and what goes into those prompts. And then we have more agentic AI where we see things going to monitor security in real time, protecting against threats, quarantine part of the network if there is a security threat in near real time and responding rapidly. Agentic AI has that benefit by processing many, many data points at once and making decisions that are much faster than what humans can do. And also from a networking side, help rerouting traffic for performance perspectives, helping troubleshooting and outages and all that. So we're going to expect a lot more. So a lot of things going on with AI that we can expect in the future about changing how we operate. Now let's talk about post-quantum cryptography. In short, a lot of people think, why should I worry about this now? Quantum computing is not going to happen for at least 5 years now. Why do I worry about this? Well, the reason to worry about this is because of protecting against harvest now, decrypt later. What that means is, even though we don't have the quantum computing today for the most part to decrypt a lot of the encryption that we have out there today, hackers can compromise data and take data that's encrypted, store it until there's a time when the quantum computing is ready to decrypt that traffic. So the challenge today is not whether it can be decrypted, it's that the traffic get hacked and data is stolen and decrypted at some point in the future when quantum computing is ready to decrypt that. So the solutions today is to implement this post-quantum cryptography today. So if anything is hacked, it's protected against a future quantum compute decryption. Sovereign SASE. So there's a lot of geopolitical things going on. I don't have to remind anyone for that. There's always that going on. So there is an aspect of that users and corporations don't want to necessarily put all their traffic in the cloud. But if they do want to put in the cloud, they want it in country. So that certainly satisfies. But there's some who want it on-prem in their control. So Sovereign SASE offers the opportunity to put your SASE wherever you want to, in the cloud, in a data center, at a colo, wherever you want as a customer with your control. That's fundamentally what this is. It's not a major part of the market, but it's one of the deployment models within the market. It's still primarily cloud delivered. Next, we have support for unmanaged devices. And by and large, this is saying, look, we have more and more devices, IoT devices, BYOD devices that are transient, unauthorized, that need to access a network that necessarily are not managed and controlled by an organization. So how do we protect the organization from these types of scenarios that are, again, transient and not in the control of the organization? And here are some examples, and that's going to become more and more of an issue going forward. So as we bring this all back together, and I know that's been rather quick, we want to talk about two things that stick here as far as the presentation. One is what's driving SASE is the hybrid work. Again, workers anywhere. So I need to access workloads that are anywhere, and it's driven by cloud adoption. So again, apps are not in the data center primarily, they're distributed pretty widely in the cloud. Workers are not only the campus, they're in the campus, in the branch, but also work in the coffee shop, working remotely, hotels, you name it. And that's where SASE is kind of meeting both these sides. As far as use cases, there's many, but here are just examples. Vendor consolidation. Organizations, customers like, for the most part, to deal with less vendors. You're seeing that. Zero trust platform. How do I just go into what the default position is to deny access? And you have to prove access and go through that process. And that's what SASE can help with, delivering that zero trust platform. Secure branch modernization, the network modernization. How do I consolidate devices, support more cloud workloads, connect directly to the cloud? All that is key. Unified, simplified experience. I want to have one management console. I want one single pane of glass. I want one policy engine. I want to simplify all this. I want to have a single pass architecture. I want to do all this, simplify that experience. And coffee shop networking is you're getting a simplified user experience from a hybrid work environment, and I can bring that remote user kind of experience, bring that on-prem and connecting that same way. So we hope you enjoyed this session today. Hope you found it informative. Thank you for your time.